Okay, so this is help on radians versus degrees / reference angles, the homework. So we want to convert this from radians to degrees. Now when we're converting from radians to degrees, that means we're going to use the formula or fraction that is 180 over pi. So I'm going to take what we're given and multiply it by 180 over pi. So we're given pi over 18, and we're going to multiply it by 180 over pi. Now the nice thing that I recognize that happens is that the pi's cancel out. So now I'm left with a nice fraction of 180 over 18. So now I'm going to take this fraction and reduce it. Now you can do this in Desmos on your calculator, whatever works for you. So 180 over 18. And now this one is very nice, and then it reduces to 10. Now all I have to do is add a degree symbol, and that is my answer. So my answer is A for this first one. Okay, so let's move on to number 2. Now this one's a little bit different. It's just 3 radians. Now you may be thinking, Ms. Smith, this might be something differently that's going to be going on. But there's actually not going to be a different thing going on. You're going to have the 3 radians, and you're going to multiply it by that same fraction, so that 180 over pi. So now we're multiplying 3 by 180 over pi. Now nothing nice cancels out this time, so what I'm going to do is I'm going to combine this. So now I have 3 times 180 all over pi. And what I'm going to do is I'm going to put this entire thing into my calculator. So I have 3 times 180, and that's divided by pi. And I'm going to get a decimal of about 171.9. Add my degree symbol, and I am done. All right. So it's going to be the same process for 3 and 4, just like number 1. Now, say I don't get a nice thing that reduces to a whole number like number 1. Now you're going to give me the fraction form. It's very important. I want the fraction form of this, okay? And remember, most common mistake is going to be forgetting that negative for number 3. So really double check that you're A, giving me the fraction, if possible, and you're keeping the same sign, whether it being positive or negative. All right. So let's now look at this. So now we have degrees 2 radians. So if we have degrees 2 radians, we're going to multiply it by a similar fraction, but it's slightly different. So now we're going to multiply it by pi over 180. Okay, so let's look at number 5. So we're going to take my degrees, so 150, and multiply it by my fraction, pi over 180. Now when I have this, it turns into 150 pi over 180. Now this is what I mean by keeping that fraction. So I want to keep this fraction if it doesn't reduce nicely. So I'm going to have 150 divided by 180, put in that in my calculator, and I'm going to convert it to a fraction because it comes out as a decimal. And 150 over 180 is 5 over 6. And the last part about this is I got to insert my pi on the numerator. And so my answer becomes 5 pi over 6, which is C. All right. So let's do number 6 now. So for this one, we have 600 degrees. Now we're going to follow the same process. So we're going to have 600 times our fraction, which is pi over 180. So now we're going to have 600 times pi all over 180. Now I'm at this point where I want to reduce my fraction. So I'm going to put into my calculator 600 over 180 and reduce it, and we get 10 over 3. So now all I have to do is put my pi back in its place, and that's my answer. So that's how I'm going to convert from degrees to radians. You use that fraction, you reduce, and you keep that sign. So again, I have to point out for 7 and 8, there are negatives attached to my degrees. So our most common mistake is going to be forgetting that negative. So really make sure you remember the negatives. All right, so then we have our last part. Find the reference angle of the following. So we have negative 945. And you're probably thinking, Ms. Smith, that's a really big number. Well, it's okay. So when we have reference angles, it's like we're going to add or subtract 360 until it's within our 360 range. So because negative 945 is negative, we're going to add 360 until it's between our numbers of 0 and 360. So we're going to have negative 945 plus 360, and we will get negative 585. Well, that's not between our 0 and 360, so we have to add 360 again. So adding 360 again, and we get negative 225. Now that's between 0 and 360, so we can mess with it now. So what I like to do when I have reference angles is I like to draw it just a little bit. So our angle, we see that it goes around once, and then twice, and then it goes around 225. And I just made a mistake. My mistake was that because it's negative, we're not going to go counterclockwise, we're going to go clockwise. So my mistake there. So we're actually going to go one time, two times, and then our remainder, which was 225, so this is 90, this is 180, and then since this is 270, we're going to be stopping here. So our reference angle, if you remember, is the distance from the terminal side, meaning this side, to our x-axis, the nearest x-axis, which is here. So it's like we're finding this distance between that side and the x-axis. So what I'm going to do here is I'm going to make it so our negative 225 is between 0 and 90. Okay, so what I'm going to do is I'm going to add 90 until it is between 0 and 90. So we have our 225, negative 225. I'm going to add 90. Okay, so negative 225 plus 90 is negative 135. Well, that's not between 0 and 90. So I got to add 90 again. So adding 90. And we get negative 45. 45 is between 0 and 90. So I now know my reference angle. My reference angle is 45 degrees. And you're probably wondering, Ms. Smith, why didn't you add 90 again? Reason being, if I added 90, we would now be over here. And I don't want to be over there. So I want to be on the left side. I don't want to go too into depth in that because I don't want to confuse you too much. But it's like the second you are between 0 and 90, you're going to take that absolute value, meaning it's just going to become positive. and that is your reference angle, okay? Let's do number 10, and you'll see what I mean. So number 10, we have negative 40. So it's already between 0 and 360, and it's also between 0 and 90. So reason being that's important, so I have negative 40. So remember, if we have negative, we're going to go clockwise instead of counterclockwise. So down to negative 40. And with reference angles, we want to find the distance between our terminal side, this side, and the nearest x-axis. And our distance is going to be this angle here. Well, if you think about it, negative 40 degrees, we already defined that as negative 40 degrees. Well, didn't we just say we're trying to find the distance between the terminal side and the x-axis? Well, we already kind of found that because it's negative 40 and the absolute value of negative 40 is going to be positive 40. So 40 degrees is my reference angle for number 10. All right, I hope this helps. And let me know if you have any questions.